Hello to everyone, and the topic is Aldehydes and Ketones, part 1. So this particular video lecture is helpful for board examination, CET examination, JEE and NEET examinations. So with this, I will move to the next slide. Next slide will give you the information about contents. So in this video lecture, we will discuss about the carbonyl compounds. What are carbonyl compounds, general formula of the carbonyl compounds, and then types, aldehydes and ketones are belongs to this carbonyl compounds. We will also discuss about the definition, general formula of aldehyde, and then definition and general formula of ketone. And also we are discussing about the nomenclature of aldehydes and ketone as per the IUPAC with examples. With this, I will move to the next slide. Next slide will give you the information about definitions. So carbonyl compounds. Carbonyl compounds, when the carbon bonded to oxygen by double bond, and this group is called carbonyl group, and the carbonyl containing compounds are called carbonyl compounds, and they are of two kinds. One is aldehyde, another one is ketone. Carbonyl carbon attached, when attached to at least one hydrogen, called aldehyde group, and the compounds are called aldehydic compounds. They are represented by the general formula RCHO. So where R is equal to hydrogen, or alkyl group, or aryl group. Alkyl group may be a CH3 or propyl, methyl, butyl, hexyl, eptyl, pentyl, or etc. Aryl group means maybe a benzene containing compounds are called aryl groups. And when R is replaced with hydrogen, it's called HCHO. HCHO is called formyl group, formaldehyde group. Hence, this aldehyde group is called formyl group. Let's move on to the ketones. Ketones means carbonyl carbon attached to alkyl or aryl group is called keto groups. And the keto group containing compounds are called ketones. They are represented by the general formula RCO R dash. So here one thing we need to notice, when R and R dash is equal, when R and R dash is having the same group or identical group, then it's called simple or symmetrical ketone. If R and R dash are a different group, then it's called unsymmetrical or mixed ketones. So with this, I will move on to the nomenclature of aldehydes. Nomenclature of aldehydes. Aliphatic aldehydes are named by IUPAC system by changing the terminal E of the parent hydrocarbon to Al. Hence, the IUPAC name of aliphatic aldehydes are called alkanol. IUPAC name of the aliphatic aldehydes are called alkanol. In higher aldehyde, the parent chain is numbered by assigning 1 to the aldehydic carbon. So with this, I will move to the next slide. Next slide will give you the information about the few examples of aldehyde, their common name and IUPAC name. So this is the one. So these are the examples of aldehydes, and these are the common name of these aldehydes, and these are the IUPAC name of these examples. So let's take the first one. This is the one, and you can observe that HCOH. So this particular one common name for this structural formula is called formaldehyde, and the IUPAC name for this structural formula is you can observe that before, as per the IUPAC system, you need to find out how many carbons are present in a molecule. Here only one carbon atom is present. That is the reason one carbon containing alkane is called methane, and the terminal E should be replaced with Al. Then it is called methanol. Okay, the methanol is the IUPAC name for this structural formula. Let's take this second one. Second one, you can observe that 2 carbon atoms is there. So for this 2 carbon containing aldehyde, the common name is acetaldehyde. Since it contains 2 carbon atoms, as per the IUPAC name, the parent hydrocarbon name is ethane. So ethane, the terminal E of ethane is replaced with AL, then it is called ethanol. Ethanol is the IUPAC name for this structural formula. Let's take one more example. So that is CH3, CH2, CHO. So for this, common name is propionaldehyde. So for this, IUPAC name is, when we are assigning IUPAC name, we have to select the, we have to check the how many carbon atoms is there. So 1, 2, 3, 3 carbon atoms is there. 3 carbon containing parent alkane is propane. So propane terminal E letter should be replaced with Al. That's because of the presence of aldehydic functional group. So IUPAC name of this moiety is called propanol. Now let's take one more example, that is CH3, CH2, CH2, CHO. And common name for this is butyraldehyde. So let's assign IUPAC name. When we are assigning, we have to numbering in such a way that the least number should be given to the functional group. That means this will be 1, 2, 3, 4. 4 carbon containing an aldehyde. So 4 carbon containing alkane is called butane. So terminal E of butane is replaced with Al. Then the IUPAC name of this structural formula is called butanol. So let's take one more example, that is CH3, CH, CH3, CHO. Okay. So common name of this molecule is isobutyrol. So let's assign IUPAC name for this. When we are assigning, we have to select a parent chain. The parent chain is 1, 2, 3. 3 carbon containing 1. This is 1, 2, 3. So 3 carbon containing hydrocarbon is propane. And we can also observe that at second position there is a substituent called methyl. Now let's assign IUPAC name for this. So 2-methyl propane 1-hal. Okay, propanol is the IUPAC name for this structural formula. So let's take one more example. So that is CH2 double bond CH-CHO. Okay, for this common name is acrolein. Okay, let's assign IUPAC name for this. When we are assigning, we have to give 1 to aldehydic functional group, second is here, third is for this CH2 group. So now 3 carbon atoms is there, 1 double bond is there at second position. So 3 carbon means propane. Say there is a second position ene is there, and the terminal Al. Okay, E of the propane is replaced with Al. Now the IUPAC name of this molecule is prop 2-ene Al. Prop 2-ene Al is the IUPAC name of this molecule. Let's take one more example, that is CH3, CH, double bond, CH, CHO. So for this molecule, the common name is protonaldehyde, and IUPAC name for this, when we are assigning IUPAC name for this molecule, we have to numbering from this carbon, aldehydic carbon, that is 1, 2, 3, 4. That means at second position, ene functional group is there. So ene is the substituent. This is the parent functional group. So now, so since it contains 4 carbon atom, 4 carbon containing alkane is butane. At second position, ene is there. Okay, and the terminal butene terminal E should be replaced with Al. That is the reason but 2-ene Al, 1 Al is the IUPAC name of this structural formulae. So let's take one more example, that is CHO, CHO. So CHO, CHO, common name is glyoxal. Okay, and let us assign IUPAC name for this. So 2 carbon atom is there. That is the reason parent hydrocarbon name is ethane. Since it contains two aldehydic functional group at 1 and 2 position, then ethane 1,2 diol Al, okay, is the IUPAC name for this molecule. Let's take this one. This is one example of aromatic aldehyde, and this is the benzene ring, and this one is carbaldehyde. So, and for this aromatic aldehyde, the common name is benzaldehyde, and the IUPAC name is benzene carbaldehyde. Benzene carbaldehyde is the IUPAC name. So let's take one more example. So you can take that this is the benzene and this position is 1, this position is 2. So for this molecule, the common name is aldehyde. For this molecule, the IUPAC name is, you can give 1, 2. So that means at 1 and 2 position, benzene contains 2 aldehydes. So that means benzene 1, 2 dicarbaldehyde. Benzene 1, 2 dicarbaldehyde is the IUPAC name. So now let's take one more example. So that is benzene means C6H5 also we can call this group, and this CH double bond CHO. So this for this common name is cinnamaldehyde, and let us assign IUPAC name for this. When we are assigning IUPAC name for this, we have to select a parent chain. So in this, the parent chain is 1, 2, 3. Okay, 3 means prop, and there is a double bond, and there is a substituent at third position. Name of the substituent is phenyl. So that means 3-phenyl is the substituent, 2-ene is the double bond, and propane. Okay, 3-phenyl, 2-ene, 1-al is the IUPAC name. This is about naming of an aldehyde, their common name, and then IUPAC name. So with this, let's move on to the next slide. Next slide will give you the information about the nomenclature of ketone and their examples. So when we are naming a ketone, the terminal E of the alkane is replaced with ONE. Okay, so that is the reason it is called alkanone. Okay, and one more thing, when we are assigning numbers numbers to the parent chain in such a way that the least number should assign to the carbonyl group, carbonyl carbon. So two things we need to remember when we are naming ketone as per IUPAC name. The terminal E of alkane is replaced with ONE, means one, and one more thing, we have to assign a least number to the ketonic carbon. These two things we need to remember when we are assigning a IUPAC name to the ketones. So these are the examples of ketones. These are the common names of these ketones, and these are the IUPAC names of these ketones. So let's take one by one. So you can observe that this is the CH3CO CH3. Okay, this molecule common name is acetone. This is also called as this is methyl group. This is also methyl group. So dimethyl ketone is also a common name for this molecule. So let us assign IUPAC name for this. So 1, 2, 3, 3 carbon containing ketone. 3 carbon containing ketone, 3 carbon containing alkane is called prop. Since it contains ketonic functional group at second position, we can say that prop 2 2O is the IUPAC name for this molecule. Let's take one more, that is CH3, CH2, CO, CH3. So you know that this group is called ethyl group. This group is called methyl group. When we are naming as per the common system, so this ethyl means ethyl group and methyl group. E of the alphabets comes first, then methyl. So that is the reason ethyl methyl ketone is the common name or trivial name for this molecule. And now let us assign IUPAC name for this. When we are assigning IUPAC name, two things we have to remember. When we are numbering the, we have to select a parent chain, 1, 2, 3, 4. 4 carbon containing one is the parent chain. And when we are numbering, we should assign a least number to the ketonic functional group. So in that way, numbering from this side is more correct compared to this one. That is the reason at second position ketone is there. Since it contains 4 carbon atom, the parent alkane name is butane, and the 2-one, butane 2-one is the IUPAC name for this structural formulae. So let's take one more example. So this example contains CH3, CH2, CO, CH2, CH3. So one thing also we can say that, so it contains ethyl group here, here also ethyl group. That is the reason the common name for this is diethyl. One ethyl group here, one ethyl group will join diethyl ketone. Diethyl ketone. This is the ketonic functional group. So common name of this molecule is diethyl ketone. Let's assign IUPAC now. IUPAC means we have to select how many carbon, means parent chain. So that is 1, 2, 3, 4, 5. 5 carbon containing one is the parent chain. And so we can assign number from this side or this side because it is a symmetrical ketone. So now at the third position, ketonic functional group is there. So since it contains pentane, 3-one is the IUPAC name. Let's take one more example. So you can observe that this is the methyl group and this one is the propyl group. So this is a unsymmetrical ketone. So since common name for this is methyl propyl ketone is the common name. And when you are assigning a IUPAC name, we have to number from this side because ketone takes least number. So 1, 2, 3, 4, 5. 5 carbon atoms is there. So pentane 2-one is the IUPAC name of this structural formula. Let's take one more example. So this is the one. You can observe that this is one kind of group. This is another kind of group. That means this is methyl group. This is isopropyl group. That means this is an unsymmetrical ketone. And when we are naming this as per the trivial system, so high comes first compared to methyl group, M. So that is the reason isopropyl methyl ketone is the common name for this structure. And let us assign IUPAC name for this. So when we are assigning IUPAC name, we have to select a parent chain. So parent chain, this parent chain is 1, 2, 3, 4. So this is the one. So at 3 position, there is a substituent. And numbering, we have to do it from this carbon because this ketonic functional group attains a least number. So that is the reason IUPAC name of this molecule is called 3-methyl butane 2-O is the IUPAC name for this structural formulae. So now let's take one more example. So you can observe in this example that this group CH3CHCH3 and CH3CHCH3 are identical. So that means this will be a symmetrical ketone. Since this group and this group are same, we have to pronounce it as a di. And this group is isopropyl group. This is also isopropyl group. Di-isopropyl ketone is the common name, and let us assign IUPAC name for this structure. When we are assigning IUPAC name, we have to select a longest possible chain. So we can start giving number from this side 1, 2, 3, 4, 5. Okay. So that means second position and fourth position there is a substituent, and this is also methyl, that is also methyl. That is the reason 2, 4 dimethyl pentane 3-O is the IUPAC name for this structure. Let's take one more example. So that is CH3CO CHO. So you can also think that without this CH3, it's called glyoxal. Okay. So since it is having CH3, you can say that methyl glyoxal is the common name. And let us assign IUPAC name now. So when we are assigning, we have to give first priority to the aldehyde functional group. So this is the parent functional group, and this will be a substituent. So 1, 2, 3. So that means at second position, ketonic is act as a substituent. So the ketone, when we are making ketone as a substituent, we have to say that 2-oxopropane. 2-oxopropanol. 2-oxopropanol is the IUPAC name. Okay, next, let's take one more example. CH3CO Phenyl. So, common name for this methyl phenyl ketone is the common name, and the IUPAC name is acetophenone. Okay, acetophenone also a common name, but the common name itself is retained as a retained in a IUPAC nomenclature. So for this also to phenyl group, this is also phenyl group, and the common name for this moiety is diphenyl ketone, and the IUPAC name is benzo. This group is benzo, and this is phenone. Benzophenone is the IUPAC name. And let's take one more example. So without methyl, it's called cyclohexanone. With methyl, it's called methyl cyclohexanone, but we have to assign number. So this will be 1, this will be 2. So in IUPAC system, we have to assign 1, 2. In common name system, we have to assign this carbon is alpha, this is beta, this is gamma, this is delta. So that means alpha position methyl group is there. Methyl cyclohexanone is as per the common system. 1 methyl cyclohexanone is as per the IUPAC nomenclature. So with this, I will move to the next slide. Next slide will give you the information about the conclusion. So that means carbonyl compounds. Carbonyl compounds, what are in this video we learned about what are carbonyl compounds and their types, aldehydes and ketones, and also we learned about the nomenclature of aldehydes and ketone as per IUPAC with examples. So with this, I will say thank you.